Good morning, everyone. I am Marial R. Bataluna from Bachelor of Science in Mathematics. In this video, I will discuss about the basic concepts on lines and also on curves, together with my partner Nika Batiansila with their topics.
Good morning, everyone. Good morning, Mariel. I am Nika Batiansila from the Bachelor of Science in Mathematics. Together with Mariel, in this video, I will discuss about the slopes of parallel and perpendicular lines. So sit back, relax, and enjoy watching.
I forgot. I didn't finish the design last night. I'm dead now. Good morning, Miss Nika. This is the design of the building. Please look at it and tell me if there's something wrong.
This is the perfect design for our project, Riel. Thank you so much for this. Let's go to the site.
Okay, Nika, let's go. Zoro! What did you do? I said within the lines. Look at the lines. Do you know what lines mean? A line is a one-dimensional figure that don't have a width and had only a length. Gosh, you should know about it, especially when it comes in this field. Lines is very important, especially when we make polygons. Look at the triangle. It has three lines that were connected to each other. Look at the square. It also have four lines with the same length. Do your work properly.
Mr. Foreman, chill. Be careful with your heart.
I'm sorry, Mom. It's just that my people, they did the work wrong.
Anyways, Riel, do you know about lines, right?
A line has no end and it is infinite. It can be defined as a straight set of points that extend in opposite directions. Also, there are two parts of lines. The line segment, which means a part of a line that has two endpoints and it is finite. The other one is the ray line. It is a part of a line that has one endpoint and it will extend in one direction only. Also, lines has four types: the horizontal line, vertical line, parallel line, and the other one is a perpendicular line. A horizontal line is a straight line that goes from left to right or right to left, while a vertical line is a straight line that goes from up to down or down to up. Parallel lines, on the other hand, it is a straight line that do not intersect at any point. Two lines that will just face each other and never touch or intersect. The last one is the perpendicular lines. It is the line that intersect at a right angle or in 90 degrees. Those lines that intersect each other and it forms a 90 degrees angle, then it is considered as perpendicular lines.
Well, that's Mariel for you. Anyways, is curves and lines are the same?
They're not the same, but curve is part of lines. We can say that it is a curved line when the line is not straight and if the point don't move in one direction. In other words, a curve is defined as a collection of points that resemble a straight line that connects two points.
Oh, I thought they are the same.
Wait. Don't make it straight. Bend it a little more.
He really worked hard.
Yeah, but speaking of bends, curves has four different types. The simple curve, non-simple curve, algebraic curve, And the last one is the transcendental curve. Simple curve is a curve that doesn't cross itself while changing its direction. It can be open or closed. Non-simple curve is a curve that crosses its own path. It means that the curve will intersect when it changes its direction. The algebraic curve is present in a Cartesian plane. The zero set of a polynomial in two variables is a fine algebraic plane curve. And the last one is the transcendental curve. This curve is not the same with algebraic curve. When the curve doesn't represent any algebraic curve, then it means that the curve is a transcendental curve. This curve has a straight line and also it has lots of intersecting points. This curve also is not part of a polynomial based on a and b. If you are still confused, here is the difference between the curved line and the line. Lines don't bend and it should be straight line. It is one-dimensional figure. It has no width and has only one length, while the curved line are lines that bend. It intersects when moving to another direction. It changes its direction. It can be open or closed. Now, do you get it, Nika?
Yes, I understand. Thank you for the information, Riel.
But you know, when I read a book last night about the slopes of parallels and perpendicular, I didn't understand even a little. Guys, being an architect is not okay at all.
Cheer up, Riel. Anyways, I have some information about the slope of parallel and perpendicular lines. I can help you enlighten your mind about it.
Really? Thank you, Nika.
As far as I know, parallel lines have the same angle of inclination. For example, the floor and the ceiling of a house are parallel to each other. Mathematically speaking, two lines are parallel if and only if they have the same slope where two such lines will never intersect. However, there are infinitely many lines that are parallel to a given line. This is because parallel lines can have different x and y intercepts. Since there are infinitely many possible y-intercepts, there are infinitely many parallel lines.
But how to find the slope of parallel lines?
Finding the slope of a parallel line is simple as long as we understand the definition of parallel lines and how to find slope generally. We can distinguish two cases for finding the slope of a line parallel to a given line. Either we already know the slope of the given line or we do not know the slope of the given line.
Do you mean there are two ways?
Yes, the first one is finding parallel lines when slope is known. If we know the slope of the given line, the slope of the parallel line is exactly the same. We may be asked to find the equation of a particular parallel line. If the y-intercept of this line is known, we can easily plug the slope and intercept values into the slope-intercept equation. Alternatively, if another point other than the y-intercept is known, we can plug the values in the point-slope equation. Then it is possible to solve for y, thus converting the equation into slope-intercept form. The second one is finding parallel lines when slope is not given. In other cases, we may be given a line with a verbal description or graphical depiction without a given slope. If this is the case, we will have to solve for the slope before finding the slope of the parallel line or lines. Recall that we can solve for the slope of a parallel line as long as we know 2 points. Often verbal descriptions will include these 2 points. For example, we may know that a line passes through the points 1 and 3 and 3 and -4. Alternatively, we may have to find 2 points if we are given a graphical depiction of a line. In either case, the formula for slope is m equals y1 minus y2 divided by x1 minus x2.
Nika, how about the perpendicular lines?
Two two lines are perpendicular if they meet at a right angle. For example, in the coordinate plane, the x and y axes are perpendicular to each other, just as there are any infinite lines parallel to any given line. There are infinitely many lines perpendicular to a given line. This is because perpendicular lines will meet at exactly one point, and for each point on a given line, there exists exactly one perpendicular line in two-dimensional space. Because there are infinitely many points on a line, each line consequently has infinitely many perpendicular lines. Next is the slope of a perpendicular line. If two lines are perpendicular, their slopes are the opposite reciprocals of each other. The opposite reciprocal of a number is the reciprocal with the opposite sign. If the slope of a line is positive, then the slope of perpendicular line is negative. On the other hand, if the slope of the line is negative, then the slope of the perpendicular line is positive. Lastly is about finding the slope of a perpendicular line. As this is the case with parallel lines, it is much easier to find the slope of a line perpendicular to any given line if we already know the slope of the given line. If not, we have to find the slope first. As always, we do this by dividing the change in y values for 2 points by the change in x values for the same points. Once we know the slope m of a line, we know that any line perpendicular to it will have a slope that is opposite reciprocal of m. That is, the slope will be negative m, negative 1. I hope it will help you with your study, Riel.
Yes, it's a big help. Now that I understand the slope of the perpendicular and the parallel lines, it's easy for me now to read that book. I'm so excited!
Now that we're done checking the design and the site, let's go back to the office. Mr. Foreman, take care of the things here. We gotta go.
Okay, Nika. Mr. Foreman, good luck!